Good morning. I joined Cash App 5 years ago, and so something was really surprising to me. So even though someone of the team was doing talks about how we should abstract our testing as well, the way we abstract our production code. So even though there were talks about testing, the Cash App didn't have any test at the time. There were no presenters. Everything was in the view. I guess the team was small enough to handle the complexity without getting beaten back. But so 5 years has passed. We now have maybe 1,000 modules. We are maybe 60 Android engineers. And for some reason, recently I've been really enjoying developing on Cash App. And so this is the result. This talk is the result of my thinking over this. Android provides some APIs, could go kind of low-layer activities, services, these kind of things. And over time, Google has been providing other APIs, and so the most recent would be all the Jetpack libraries. And what they do is kind of creating a bridge between the lower-layer APIs and your app, just to make things more simple for everybody. And there is something that Diane Hagborn has said many years ago. So she's part of the Android team. I don't know if she's anymore, but anyway. So the most important part for me from this quote is at the end. It basically says, we created APIs for you to talk with the device, let's say. But on top of this, you should not care about the Android APIs anymore. You just do whatever you need for your app. And so Cash App took the decision many years ago to create those bridges that Google has been providing recently. So we have our own navigation library. We don't use view models. We don't use fragments, a few things like this. And so I'm going to show what we've been doing and how we have been doing them. So first, the UI. This is until a few years ago what we would have. So we would have custom views for any view that we need. We would use inflation inject if we need it or not. We would pass in a constructor some payloads, even the presenter. Then we would just make sure that events go through the presenter, get back to be rendered. We need to handle the lifecycle of the stream, and so we would just unsubscribe when the view detaches. And it felt good at the time, but there are a few problems. The view is injected with some payload that makes testing difficult. And now we need a dependency on the presenter module as well, unless you want to go and create interface thing that we had at the very beginning of MVP, I think. But anyway, when we look back, it's not good at all. This is the flow model that I have in mind, and so I guess that we all have. It would be really similar to maybe Cycle.js or anything MVI related. It's just one circle of data going only one way, one unique way, so unidirectional data flow. Event emitted by the UI would go to the presenter. They would either create side effects, so I don't know, network requests, something saved to the database, navigation, and sometimes emit view models. So when I say view model, it means view model, not presenters. And so the presenter would just emit a model. The UI gets it, render, and that's it. And there is one, the graph is simple, but at the same time, because it's simple, it's meaningful as well. Like the UI should not talk back to the presenter to ask for more information about the model. It can only send event. So if the model is incomplete, the UI should not be able to render it. We want models to be self-sufficient to render any screen. And so it implies that the UI should not have any state. Like obviously there would be some input or maybe the scrolling position, but ideally that's it. And something else that we are missing here, it would look like the UI would, by getting a model, emit an event, which is a lie, because in the middle we have our customer, or our user, however you want to call them. And that means that the UI, whatever model it receives, should never send an event. It can create really, really difficult situation to debug, and like in a, theoretically create an infinite loop. So the UI receives a model, renders, stop, and when the customer taps something, scroll, whatever, we send an event to the presenter which deal with it. And so we're going to see this screen multiple times throughout this presentation. Read-only screen, really simple, some text, some image. We have two buttons, and the model and the event would look like this. Basic POJOs, there are no callback, no logic into the model. And the events, right now are only objects, but if they had payload, they would be data classes. So it would be a text input or whatever. And so the close button would be at the top. It would just close the screen. And the CTA clicked would just mean the customer has pressed this button. How we would create it in the UI. So the contract that has been defined by the graph is referenced as a UI model as in the UI event. We want to be able to pass basically a callback to say, hey, if you want to send event, just send them there, which is what we do. And the other one is, hey, here a model I want you to render. Nothing more, nothing less. And we kind of deliberately not use, we didn't use any RX, flow, any dependencies to keep the view modules just as simple as possible. And in the implementation, it would look like this. So we have just a random view. We would, however we want to define the buttons and things. The two methods we need to override. So the receiver, we would just, we can either store the event receiver and pass it later, or maybe to adapters for recycler view or whatever. But so here we're just using the basic Android API, set on click listener, you send this event, and for the toolbar navigation, click listener, do this. And the model is, take this text, assign it to this field. If we had images, it would be just, load the image via Picasso or something. Nothing fancy. And with Compose UI, we would have something like this. So we created our own abstract class on top of abstract Compose view, which makes things different because Compose UI kind of needs you to give the model right away, and that's why it's notable in our case. And that's the only difference. Before, we could do set model and not call it. For Compose UI, we have to override this method that we created, so we pass it as nullable. And so what's really nice about having this simple interface and this simple implementation is that tests are really easy to do. Those two screenshots are not screenshots that I made myself. They are the results of UI tests that we have been writing using Paparazzi, which is a library that we've been developing in-house, which is open source as well. And this is an example of a test. You define the Paparazzi rule, and so you can define the theme. You can say you can set the device configuration if you want a Nexus 4, this dimension, like anything you can think of. In the test, because it's so simple, you instantiate the view. If it's in, if it was in a layout XML, you can just inflate it as well. You set the model, and then you take a snapshot. That's it. If we want, so you saw there were two screenshots, one dark mode and one light mode. And so here we use, I forgot the name of the library, something from Google, maybe test parameters. injectors, I guess, which is, so you can see to the test class we pass the design theme annotated with test parameter. This is an enum class, and so this library would take every value for this enum and just run a test per value. And so the design theme would be, we have dark, light, and the rest, the test would be run twice. And so we would just wrap it around our context and do our magic. It supports Compose UI as well. The API is the same. Paparazzi, snapshot, bang. So what does this do? Every time you run the test, it would create a report where you would be able to see every time you run the test, basically. And so it's really easy to see how it's going. And it's almost kind of a test-driven development. And this is what the reports would look like. And so the left would be light and dark on the right. So you can navigate between screenshots, you can see the differences, and you just iterate until you're happy. And we didn't run any emulator until now. Everything is super fast. Running the test out, I don't know, 1-2 seconds. And this is how would you integrate Paparazzi into your workflow. So you write the test, obviously. Then you would record them. And so every time you would record them, they would be created under so test snapshots images. We see 2 files, one for the dark theme, one for the light theme. And those files would be checked in to your repository and would be basically used as golden files, which is kind of a source of truth against which we can be sure that like the view is still rendering properly. On CI, you would be running the verify task. And this one on CI would generate, again, everything and compare the files with the golden files. If it fails, the test fails. And so in the details, it will tell you, OK, the images I have differ by this much. This is also configurable, so you can say 1%, 10, whatever. We try to keep it as minimum as possible, obviously, but they are kind of metadata depending on which machine you generate the images on. So I think we have like 0.1% or something like this. And if it fails, it's also kind of nice. It gives you a delta image that you can just look at and see the differences between the 2 screens. So if someone, I don't know, if you have some shared design components and someone changed something and your view has been affected, CI will fail. And you'd be able to know, is the change proper? And then you generate, again, everything check-in. And otherwise, you know that the implementation that details has leaked, and you need to do something. And so, as I said, the really nice thing as well is that it runs on the JVM. No emulator, everything is super fast. And we've been enjoying it really much, very much. OK, presenters. So, like the view, 2 parameters, the model, the event. And so we would think that we get the models as a flow and a method to just send an event, which, as we've seen, could be close, something has been clicked, something input, whatever. But so we wrapped it around a binding interface, because the trick about presenters is we don't want them to be doing anything before they have to do. And so they have to, so anything in the init or in the constructor saying, OK, call this database, call this network, like whatever, we would usually be against that. You would be exposing the flow models. And to force the call site to think about the lifecycle of the presenter, we create this binding that you only get if you call the start method by passing a scope. And so the scope would be used by the presenter to know when to just tear itself down. So once you have the binding, you can just take the models, pass it to the view, and the send event would be the reverse. And so we have it to do in our code, and we are exposing a flow and not a state flow for legacy reasons, because, for instance, if you had a flow or an observable, you can subscribe and still not receive any default event. You can just wait, kind of a suspend method, until you get the first model. And as we see in Compose UI, we want something from the get-go. And because we still have Rx and flow presenters, we have this to do, but at some point we would want the state flow, which would give us a default model to pass to the view right from the beginning. And it's also to show that we are still iterating over everything and working on this. So on this graph, even though the UI was tricky because the customer is in between, the presenter is itself kind of a map operator. You pass an event, you get a model. And sometimes you don't get a model because there are side effects, but it's not really a problem. In Rx, this is represented as an observable transformer. We created one coroutine presenter. So the same, we pass a flow of events the presenter would subscribe to, and a flow collector for the presenter to say, okay, emit this model. And like this. This is one example of the observable transformer. So the logic is pretty simple. We inject string manager to be able to do context, get resource, kind of behind the interfaces for easy testing. We have a database and an I/O scheduler. So we first look at the events. We do some magic, but basically, if we have a CTA clicked, we want to do this, start a flow. If it's go back, we do so. Then we also need to define the stream for the models. So we look up the database. We fetch the data that we need. We use a start with because we kind of provide a default value for the model, and then just map the result to a model which will be emitted. And so because it's a stream bound to the database, every time the database changes, the value of this table anyway, a new model will be emitted. And somehow the screen, although simple, for the presenter, it's already wrapped into transformers, and that's a bit sad. But again, because the interface is really simple, the testing also is. To test models, we just subscribe to the presenter. We use an Rx rule to confirm that there are no unconsumed model or anything left. And we just subscribe, we get the default model. Okay, we assert that it's the right one, we are happy. If we need to check side effects or anything, we just passed CTA clicked. We check the navigator. Did we go to this screen? We are happy. Easy testing. We don't mock anything. If we have like I don't know, repository classes or things like this, we would fake them. But we always try to just keep things as simple as possible. And so Molecule got released a few months ago, I think last year. And it's a library that so Cash App has been enjoying a lot. And it started from this. So it's part of Jetpack Compose. And Compose UI would allow you to create things like this. And the most important thing to me is the add composable annotation, because it's magic and makes everything reactive, even though you don't see anything reactive in this. And so this code actually kind of doesn't change, but if message was backed by a flow or a mutable state, every time this changes, the content method would just kind of dirty itself, compose again, and render something new. And this reactivity being hidden away was really appealing. And we were imagining, what if we could do something like this? But not creating UI, but just returning models or objects. In this case, we have two flows. We collect them as states, so we kind of make them into multiple states. And because we are using delegates, it's kind of hidden away as well. And we simple if statement, which kind of unseen in Rx and maybe less so in a flow. If the user is null, we return this, otherwise data with the username and the balance. And so again, even though it doesn't look like it is, everything is reactive. If the user flow emits something new, if the balance emits something new, the method would be composed again. And instead of returning loading, we would return data. And if the, I don't know, the name of the balance changes, it would emit again. And molecule is the response to, okay, I have my composable method, that's really cool, but how do I bind it to the rest of my code? And that's what molecule does. Molecule takes a composable method and gives you a flow out of it. We have two, and that's all it does. We have two really small APIs. So one is molecule flow. You pass a clock and the composable method. And the clock is, we have the context clock, which is basically what you would get if you were to run in Compose UI. So more or less, what is it? Reference to the frame of your device. And immediate would be, if there is anything dirty right now, we just emit again. It would be really eager, while the other one would be waiting, let's say, for a frame tick to do so. So this one, molecule flow, gives you a flow. And we have another one, which you have to call on a scope, which gives you a state flow. And as we've seen, state flow is kind of hot, flow is kind of cold. That's more or less the difference. And that's how we would use it. The profile presenter is the composable method that we just saw a few screens ago. And molecule allows you to do the transformation, which is actually quite powerful. And so we have observable transformer for people doing Rx in the presenters. We have coroutine presenters. And so the last kit to the block is molecule presenter. Composable models, we pass a flow of events, and like the signature, it returns a single model. But because of the annotation again, it's actually reactive and would emit a model every time it would need to. And that makes the code quite simpler. So it's the same, the presenter for the same screen, so the logic is the same. We first kind of subscribe to the events to do our side effects. We can use a when statement. Again, difficult previously. We defined a stream for the toolbar title. So again, we connect to the database, collect a state. So now it's mutable state, kind of hidden variable. And we have a simple imperative return statement, which, even though it's this simple, emits again every time the toolbar title would change, in this case. And this is the magic that Molecule allows for us in presenters. The testing, we don't need to add anything because using Molecule, we will get the composable method, get a flow out of it, and then we use ToBind, which is a flow testing library that Cash App has been developing as well. We await an item, which would be a model. We assert that it's equals something, happy. And again, for side effects, we send an event, confirm that the navigator navigated somewhere, and it's a breeze. And so we also have been using it outside of presenters for anything that is basically emitting. So there was a state manager somewhere that I had to write, and I decided to use a Molecule for this. And again, even though it's using kind of reactive logic, everything is just imperative and simple. And if used in a Molecule presenter, it will be just called as a method directly, which is also nice to see. So how do we go from different UI to other UIs? We have really kind of the root type screen, which extends parcelable because we use it when we store and restore states. And an example of a screen would be the stock details. We have the payload, which would be able, it would be enough information for the presenter to know which stock, in this case, to load. We could have whatever we want, and we would just pass it around to the navigator, which the only API is go to somewhere. Our presenters are getting injected by the navigator, and the presenter says, okay, I've done this, I want to navigate somewhere. And so this is part of the molecule presenter from a few screens ago. And if we want to do navigation, we would do navigator go to. We could instantiate the screen or get a reference from somewhere. Then the navigator would do the side effect of swapping views and things like this. And this comes to Broadway. It's not open source. I don't know if it will be. It's kind of the name of the in-house library that we've been using to kind of give a name to the whole thing. And Broadway is really basic. It has all the interfaces that we've seen, the UI presenter. And so it also has factories to we kind of basically do dependency injections for our presenters and UIs. And so each module, so we have an investing module, banking module, activity module, they would all expose their own view factory, and likewise for the presenter factory. And the logic would be basically, hey, I have this screen, do you have a view for this one? And we would just go all view factories until we get one, and the same for the presenter. And and so, even though, I'm sorry, I'm coming back, the presenter factory returns a presenter, but we've seen so far only observable transformer, coroutine presenter, and molecule presenter, no presenter per se. And so we have an extension function that we can apply to all presenters, which would get the original type and make it a presenter. And it's basically just a bridge of making sure that events are getting passed to the presenter, that we get the model back and emit them when we need to. We use the scope to make sure that the lifecycle is respected. So we only start subscribing to whatever presenter we have when start is called. And when the scope is canceled, the presenter shuts down. We have one for observable transformer, one for the coroutine presenter, and lastly for molecule presenter. And so one for each. That means that in our presenter factories, in the same module and like in the same app, we could have any type of presenters that we want without causing trouble, and they can coexist. It's really easy to adopt a new technology without having to migrate everything. Like, I don't know, like RX1 to RX2, RX to Flow. There was always a mid-step that was causing trouble. In this case, we don't have any. And another thing that it allows is we could write testing methods on the presenter type itself. And so, for example, instead of testing the molecule presenter or the coroutine presenter, we could do presenter.asPresenter and test the result of it. That means that if we have tests written this way, even if a migration happened for the presenter, so going to observable transformer to molecule presenter, the test don't need any rewrite. And they actually make the migration safer because the test already there to confirm you that the logic hasn't changed. And so if we get, I don't know, the next thing after molecule or whatever, we could adopt it without any cost, basically. And so we have those two factories. We have a third one, which is about transition. And so again, we would ask any module, I'm going from this screen to this screen with these conditions. Do you have a transition you want me to do specifically? And if we have one, we just return it. This is an example of a view factory. We have a big when statement on the screen. And so if it's this screen, so dependent welcome, we return this view which all written in Kotlin, so we can just return it. If there needs to be assisted injection, we would pass the factory, just create it on the spot. It would be really easy to use feature flags. So depending on condition, if you want to show one screen or another, this could happen here. And lastly, if we have some XML, we can do so as well. So like presenters, views can be written any way we want, as long as we can just pass a view object, we're good to go. An example of a presenter factory, a bit simpler, I guess. We have assisted injected presenter all over the place, basically, because we, as you see in the create method, we pass the navigator and sometimes the screen as well, which are, so the screen is the payload which identifies, so for stock details, what kind of stock we want to show. And the navigator is, because of implementation details, something we want to inject, because we kind of deal with scoping sometimes. And then at the end, we see the extension as presenter, which transforms whatever type of presenter you wrote. We're going to return a presenter at the end. So all modules, add them to the DI graph, and the glue will take care of it. So we provide Broadway, which receives all the view factories, all the presenter factories, and we just return it. And Broadway would, in a really simple world, when it receives, so the navigator would receive a go-to, and it would be, okay, I have this screen, give me the presenter, or find the presenter for this, find the UI for this. When I have the two, I just bind them and make sure that the data flows properly. And so I don't really know if Kashav took the right decision, but actually kind of wanting to do everything yourself is tiring. And so if you want to try it, you can hook up everything, and then you just draw the rest of the YAML. And so in more details, this is what would happen inside our app. We have a navigation to a screen. We need to know first, is it a full screen? So is it taking over the, everything? Is it an overlay, so dialog, a bottom sheet, whatever we want? Or is it meta? We have some meta screens like a back screen or like a finish, which would be, say you're in a dialogue and you press the positive response. We want to give that back to the view behind. This would use the finish thing. If it's back, the navigator would know to just pop one screen up the stack. We do some backstack management. We tear down the old presenter, which using the scope is sufficient to do. We save the UI state because we might come back to the screen or whatever case we have. We create the new presenter. Again, we have all the factories. We just loop through them all until we find the first non-null presenter. We start it using the scope that we created for this one. We create the UI again, going through all factories for the UI. If we have a state saved for this UI, we just pass it to it. We do the binding, which is basically using a scope, making sure that the events are going from the UI to the presenter and that the models are going backward. We deliver the results, which was what I talked about for dialogues or views that need to pass something to their parent. We attach the UI, runs, and run the transition from the transition factory. And if we don't find any, we would have a default, I think, swap from right or something like this. And finally, we just remove the old UI. And it would be basically a frame layout, add view, do this thing, and at the end, remove view from the old one. And this is all I had. There are some references about the libraries that I've talked about, except the last one, which I didn't talk about. It's something that people at Slack have been working on. They said multiple times that our thinking was really similar, so if you want to have a look at it, please do. And otherwise, I thank you for your time.